Okay. So we are done with the. Did we complete the second chapter as well?
Yes, teacher, we did.
Okay. Okay. Then we'll start with the third one. Any questions from the previous one? Were you able to manage everything?
Yeah, teacher, it was fine.
Okay. Now, this one also, it's actually easy. So, it's all about the measures of variation. So, when it comes to measure of variations, we will be, once we completed this entire lesson, we will be able to find the different measures of variations. These are some learning outcomes which we will satisfy. I'll go to the theory parts as well. So here, first one is they are like giving us kind of a background. So these are few things that we need to recall when we do these simplifications in this part. That is, okay, we can't have negative values for the square root inside the square root. So it should always be equals to 0, or it should be a positive value.
Yeah.
Yeah, those are the few things. Now, if I move to the theory part, first one is how do we best summarize a set of data? How do we best summarize a set of data? Now, if we have kind of so let's assume we have two data sets. One is better A and the second one is the better B. And we have data sets. We have two data sets. One is like 25, 30, 31 wage venokota. Again, the total would be 225. We have another set of data that is 2710, but it's also equals to the total 225. So now let's assume that we have a question. We have a question. Then hitannako who will score more? Or else what would be the best one, Kiala, if we wanted to find out? Then we should have a proper method to find out the best one. एक logical, mathematical, the approved mechanism we should have kind of an approved mechanism, and also we should have reasons why we selected this one as the best one here. So
Yeah.
here, how do we best summarize a set of data? A measure of central tendency along along does not describe or summarize a set of data fully. What will happen? Last chapter we discussed about the measure of central tendencies. No, there we just talk about the median, then the mean and the mode. But
Oh,
these values are like a single values. Ne? A single
yeah.
values represent in the whole data set. Actually, actually, it's not good, right? Tara, ඔක්කොම තියෙන data set එක we can't like normally we can't define it, or we can't represent that entire data through a mean or by using a median or by using a mode. It's not
Yeah.
ethical, though we did it. So what we have a method, although it may tell us the location of the most central values or the most common values, it tells us nothing about how widely spread out the values are. So two sets of data can have the same mean, median or mode, yet they can be completely different as well. So a better description of a set of data is given by a measure of central tendency and a measure of variation as well. So variation is also known as spread or dispersion. So we should know when it comes to variation, why we do this variation, why we calculate this variation, and also another two names for this variation is spread or the dispersion. If we have an idea about the spread or the dispersion or the variation among the data set, among the data set by a measure of central tendency, then we might have a good or better or proper idea of our data set. That is what we have. So consider the runs scored by two batters in their past 8 cricket matches, which are given in the following table. So here batter A, batter B, and these are the data set. So the mean number of runs scored by A and B is the same. If you calculate this one, the total is 224. No, if we calculate the mean, then 224 divided by the 8 matches. Again, we will receive the same answer, which we call 28. From the mean value also, we can't say who is best. Who is the best batter or who is the best person here. So, however, the patterns of the number of runs are clearly very different. So, the numbers for batter A are quite consistent, whereas the number for batter B are quite varied. See, here 2 and then 70, 1, 0. That means actually the batter B is not a consistently he is not
Yeah.
playing, right? But here he has kind of an average to above 20 වගේ 25 30 31 26 එක ළඟ යන ඒවා තමයි ඔක්කොම තියෙන්නේ. මෙයා ටිකක් බැලුවාම සමහරක් දවස්වලට he is playing good but he sometimes 104 වගේ score කරලා තිනවා but sometimes actually he is nothing. එයාගේ average එක ගත්තොත් average එක ගත්තත් ඒක same but consistency එකක් නෑ එතන. So then what will happen? This consistency or consistency or lack of it can be indicated by a measure of variation. So for these kind of measures, we can interpret these kind of things from the measure of variations. So which shows how spread out a set of data values are. So 3 commonly used measures of variation are: one is range, then the interquartile range. At last, we have the standard deviation. I think the range and the interquartile range, we already did it in maths as well. Up here,
Yes.
Q1, Q2, Q3, kela calculate karna, those are the quartiles. They are interquartile range means Q3 minus Q1. That one we already know. And when it comes to range, range means the largest value minus the smallest value. That is the normal definition for the range. These two we already discussed in some cases in maths.
Yeah.
But for the standard deviation is the new one. Correct. So here
Yeah.
for the range, first one is the range. As you will recall, the range is the numerical difference between the largest and the smallest values in a set of data. So one advantage of using the range is that it is easy to calculate. So however, it does not take the most central values into account, but uses only the most extreme values. So it is often more informative to state the minimum and the maximum values rather than the difference between them. So for example, in a test for which the lowest mark is 6 and the highest mark is 19, so the range is 19 minus 6, that is 13. For group data, this one is for if we have like ungrouped row data, if we have group data, then we can find a minimum and the maximum possible range using the lower and the upper boundary values of the data as well. For example, they have given to the nearest centimeter, the tallest and the shortest pupils in the class are 169 centimeters and 150 centimeters. So then they ask us to find the least and the greatest possible range of the student's height. So how we gonna calculate this kind of thing? 169 means actually 168.5 and 150 means 150.5. So then we need to subtract these two and calculate the least possible range, that is 18 centimeters, and also for the greatest possible range would be 169.5 minus 149.5. These are two methods. Okay? මේක ඇතුල් පැත්තට මේවා වෙනවා. මේක it will be like actual range is 169 to 115. Anyway, this
Yeah.
169 rounded off from 168.5 up to 169.4, right? May ඔක්කොම
Yeah.
ones will be rounded to 169. That's why here they have considered this one,
Yeah,
160.
so the upper bounds and the
Upper
lower
bound,
bounds,
the
right?
lower bounds, yes. Okay, that's how it comes. So that is it. Okay. Can you read this? How do we best summarize part? I mean, starting from here to get
Okay.
an idea, and then we'll move to the next theory part. ඔව් තෝරලා තියෙන්නේ මම ඔයාලට පෙන්නලම දාන්නම්කෝ. ඒකේ ලොකු කාලයක් යන්නේ ඒකේ. මට හිතාගන්න බෑ යට ලා පාට එකක්ද තද පාට එකක්ද මං දාලා මං පෙන්නන්න.
එයාට හොඳ තද පාට එකක්. මේ
තද
කියාස්
ඒවා
දෙකම
උදේට හරියන්නේ නේද? එයා තෝරලා ඉන්නේ බේජ් කලර් එක.
Okay, teacher.
Okay, that is done. Then up to this point, sorry, up to this point, it's done. Then we have, okay, so that is done. Okay, so here we have the range. So when it comes to range now,
We did that.
we did that part, right? Then the interquartile range. So anyway, for the interquartile range also, we already know. So what will happen here? The lower quartile is there. So the lower quartile, actually, when it comes to quartiles, we have Q1, Q2, and Q3. So the middle quartile, we have given it another name. That is also, we call it as median. Oh, the value which is in the middle point. So here we have Q1 and then we have Q3. So these ones are the lower quartile is Q1, then Q2 we call it as median or the middle quartile. And then the third quartile, we call it as the upper quartile. So then the lower quartile, median, and the upper quartile, as you will recall, divide the values in a data set into four parts with an equal number of values in each part as well. So these three measures are commonly abbreviated by these values. So the interquartile range is the numerical difference between the upper quartile and the lower quartile and gives the range of the middle half of the values. So as shown in the following diagram, these are the like main quartiles and the spread, actually how it has been spread among the entire data set. So these are the few keywords which you should know. So the interquartile range is often referred to the range because it gives a measure of how varied the more central values are. It is relatively unaffected by extreme values. That is more important. If they ask us to give reasons, we need these reasons to give. So all so-called outliers and can be found even when the exact values of these are not known. So what will happen? The interquartile range is often preferred to the range because it gives a measure of how varied the more central values are. And also we can find out what are the outliers. That means the unaffected. This interquartile range is relatively unaffected by the extreme values. Another name for these extreme values is outliers. So then, normally, how we calculate these outliers and can be found even when the exact values of these are not known. Actual values are not, though we don't know the actual values, we can identify what are the outliers as well because of these quartile ranges. Now, for the ungrouped data, the positions of the lower and the upper quartiles depend on whether there are an odd or even number of values in the set of data. One method that we can use to find the quartiles is as follows. What are those? For an even number of ordered values, we split the data into a lower half and an upper half. Then Q1 and Q3 are the medians of the lower half and the upper half respectively. So first we divide the entire data set. First, we divide the entire data set into two parts. We are splitting our complete data set into two parts. One is for the lower half. The other one is for the upper half. And then Q1 is the middle point or the median of the lower half, and Q3 is the median of the upper part. Upper part means the upper half. So then the median of the lower half and the upper half respectively. So for an odd number of, that is only if we have an even number of data set, because we can divide that entire data set into two separate.
Yeah.
That's what we have for the even number of data set. Habai, if we have like odd number of ordered values, then we split the data into a lower half and an upper half at the median, which we then discard. So again, Q1 and Q3 are the medians of the lower half and upper half respectively. So for example, look at this 3.2, then there find the interquartile range of the 8 ordered values. So these numbers are already ordered. If they have given us kind of an unordered values, then the first task we should do is we need to make this entire data set as an ordered one as well. ඊට පස්සේ
Okay.
then, okay, give me 1 minute.
Okay.
So here, what will happen? Now, okay, so that is it. So here, if the entire data set is not ordered, then first thing we have to do is we have to make it as ordered, and then we need to find out Q1, Q2, and Q3. එතකොට here the number of values are 1, 2, 3, 4, 5, 6, 7, 8 anyway, even number of data set. එතකොට first we have to split this entire data set into two groups. එතකොට for the first half, we have 2, 5, 4, 9, 13. That is all four numbers. Then we have 29, 33, 49, and 55. That is for the last four. So here Q1, Q2, Q3. Then the middle point of the again median of the first half, and then we have the median of the second half. That is what we have. So here answer will be 2, 5, 9, 13, 29, 33, 49, and 55. Normally, how we gonna calculate the middle point? That is 5 plus 9 divided by 2. Here we have 33 plus 49 divided by 2. And then we need to take the range or the interquartile range among these two. That's what here we have. So in example, okay, that is clear, right? Up to this point. Can you like
Yes, teacher.
read this 3.2 and then we'll do the examples.
Okay.
Right? Hmm.
Okay, teacher.
Okay, that part is done. Then, can you work on the example 3.3 and 3.4?
Okay. Okay, teacher.
Okay, those examples are also done. Then, these two also done. No questions at all. Then, the median is the way between the smallest and use your results and okay, the explore 3.1. Can you give the reasons for these ones and check? Explore 3.1 and then we'll move to the next theory.
Okay.
It's like providing some reasons, the evidences wage case.
Okay, teacher.
Okay, that's also done. Then the next part is group data. For group data, we can use a cumulative frequency graph to estimate values in any position in a set of data. This includes the lower quartile and the upper quartile and any chosen percentile as well. So the key points are for group data with total frequency, what will happen if n is equals to the total frequencies. N කියලා කියන්නේ normally the number of elements. No, that means actually the sigma, the total of summation of the total frequencies of all frequencies. So the positions of the quartiles are shown in the following table. Now, how it works, if it's lower quartile now, that is 1 over 4th value. If it's median now, that means half value. If it's uppercase now, that is 3 over 4th value. That's what we have. So the nth percentile is the value that is n% of the way through a set of data Q1, Q2, Q3 are the 25th, 50th and the 75th percentiles respectively. So in an ordered data set with say 320 values, that means we can calculate පළවෙනි එකට එන්නේ 40th value, දෙවෙනි එකට එන්නේ 160th value, and the next one it would be 3 over 4. No? එතකොට වෙන්නේ 240th value. That's how it is. Okay.
Yeah.
So then, and the 90th percentile is, if it's 90th percentile, now that means we should, anyway, the total count is 320. 320 should multiplied by the 90th percentile means 90, again, 0.9. 90%. එතකොට earth value තමයි, we need to read it from the data table. That is 288th value. So the range of the middle 80% of the data set is the difference between the 10th and the 90th percentile is it. It's clear, right, up to this point?
Yeah.
Okay. Shall we quickly go through the 3.1?
Okay. Okay, teacher.
Okay, that's also done. Then all the values are done, right? Okay.
Yeah.
We have the box and the whisker diagrams. So here we normally called it as a box plot as well. So what will happen here? A box and whisker diagrams. So a box and whisker diagram. So we normally called it as box plot. Is a graphical representation of data showing some of its key features. So these features are its smallest and the largest values, its lower and the upper quartiles, and its median as well. Now, if drawn by hand, the diagram is best drawn on graph paper and must include a scale as well. So it takes the form shown in the following diagram, which shows some features of a data set denoted by X. So now what will happen? It is 0 to 15x. Now, if it's again 15x means actually the here this one is the data bar. So 0,
Okay.
10 and 15 කියලා තමයි we have counted. Again per square that is value one value. So then in the box plot what we normally graph is these are the main features which we have to know when we draw this box plot. That is a smallest value q1, q2, q3 and the largest value. Endpoints are smallest value and the largest value. එතකොට box එකෙන් දෙන්නේ Q1 to Q3. Here we have to mark the Q2 as well. First, we should draw the data line, data points in a line, and then find out this entire box plot.
Okay.
Okay. So the key features of the data for X represented in the box and whisker diagram are the median, range, interquartile range. So the following box and the whisker diagram is a representation of a data set denoted by Y, drawn using the same scale as the previous diagram. Give me 1 minute that my brother's baby is crying. I'll go and like quickly come. Just
Okay,
read this.
teacher. Okay.
Yeah. Just
Hello, teacher.
Okay, sorry. So, what we were discussing here. Okay, now median range IQR is already done. Then, how we gonna do this? Anyway, first we need to like draw this entire data points first, and then under that, we have to draw the box plot. That's how it is. So, this is for the now. This is the initial box plot. No. Now, how it works actually? So, the following table shows a measure of central tendency that two measures of variation for each of x and y, and we can use these to make comparisons as well. So, what are those? Median, range, and IQR. IQR means interquartile range. So here for the data set, what would be the median? What would be the range? So in any given data set, we should be able to calculate all these values. එතකොට what will happen if we have two data sets like data set 1 and data set 2? So now we can have a proper comparison, right? For the median, range, IQR, all these values are there. So එතකොට we have the median values in both, that is 6 and 9. And here we have the range, that is 13 and 15. And here we have the IQR, that is the interquartile range, that is 7 and 9. Those are the all three possible what we call the dispersions, variations, values to compare among two data sets, multiple data sets. So by comparing medians, values of x are on average less than values of y. So here by comparing ranges and interquartile ranges, values of y are more varied than values of x. So we can assess the skewness of a set of data using the quartiles in a box and whisker diagram. So in the previous box and whisker diagram, for x, Q3 minus Q2 is greater than Q2 minus Q1 as well. So, and the longer tail of the arm. These three are for actually the skewedness. That day also we already talk about
Yeah,
positively skewed and the negatively skewed, and the other one is the symmetrical. If it's
yes,
positively skewed, it would be at a positive side එකට tail එක වැඩි වෙනවා. If it's negatively skewed, then the negative side එකේ tail එක වැඩි වෙනවා. If it's symmetric, then we have a proper bell-shaped curve like this. That's how we have. So if it's
okay,
positively skewed, that means Q3 minus Q2 greater than Q2 minus Q1. If it's negatively skewed now, then we have Q2 minus Q1 is greater than Q3 minus Q2 as well. So if it's symmetrical, that means both two sides should equal. That means Q3 minus Q2 is equals to Q2 minus Q1. That's how it works.
Okay.
Okay, those are the values. Okay, now on this exercise, okay, shall we do only the 12th and the 13th question?
Okay.
Okay.
Teacher, in the 12th question, how do we do part C?
Well, question part C. It was found that toxins made up between 0.75% and 2.25% of the mass of n of these samples. Use your curve to estimate the value of it. Use your curve to estimate the value of, okay, 0.17. 0 minus 4 minus, and these are the values. Okay. Okay, then we have these are the values. What do we have? N means what? 0 minus 4 minus 7 minus up until 17 minus. Okay, that is there. It's 0 to 4 to 9. Cumulative frequency is also there. We can calculate. Okay, then to calculate the P, we can calculate the cumulative frequencies and then take out the 0.75, 7/5, right? And the
So,
2.25. But if,
the
yeah,
cumulative frequency is 50.
okay, cumulative frequency, no, out of that, so out of that means,
So,
so,
0.75 out of 50.
on the right, 0.75 into 50, yth value, th value. That's how it should be, right?
But then I get like 0.375.
Mm,
0.75% into 50 is 0.37.
so for the mass of n these samples, use a curve to estimate. Okay, if you draw the curve, estimate the value of. No, if it's okay, if or draw the nth value, right? Nth value means 10 given samples here. Let me think of that. You will continue. Row.
Okay.
0 to 3, 4 to 10, 17, and 20 to 30. It's the entire one would be 30. Then we can have that 2, 19, 23, 3, 3. Draw a cumulative frequency curve. Okay, that is done. Then use your curve to estimate. Correct to two decimal places. The interquartile range. Okay, that one also can be done. It was found that toxins made up between. If it's a box plot, none, the minimum value when the maximum value would be the 0.75 and the 2.25%. It was found that the toxins made up between 0.75 and the 2.25. A interquartile range should equals to this interquartile range. By using that, we can find out what would be the number of elements there. Okay, let me check. Make an assessment of
The answer is 40.
answer is
N
40,
is,
right?
yeah, N
Uh,
equals 40.
N equals 40. ඒ කියන්නේ the total value would be 50 no. එතකොට out of 50, 10 values will be the outliers. The rest of the 40 will be among this range. For example, if it's a box plot now, you can remember, so if we draw like this, here we have the minimum value, here we have the maximum value. Out of in between these two, in somewhere around here we have Q1. Somewhere around here we have Q2, somewhere around here we have Q3. So how we draw the box here, the box will be something like this. Here the minimum value and the maximum value. Now they are asking the N. N means within this range,
But
how many
but it's
yeah.
they're asking like from the curve, not from the curve.
Yeah,
How
from the
do you?
curve. Yes, yes. That's what I'm also giving you. So here, if it's the now, what will happen? So, if I explain you with the box plot now the total number of elements is 50. Out of that 50, 40 would be lie in between this minimum and the maximum values. The rest of the 10 values are actually the outliers. Hari, එතකොට
Yeah.
that's then we have like proper idea. No? So here, okay, did you draw the cumulative frequency? Can you send it to me so that I'll
Okay.
make it? Yeah, so that I'll take it and then explain you.
Okay, Rishabh, give me a second.
Okay, no problem.
Send it.
Okay, you sent it to me. Let me open it. So I received. Okay, 30, 40, 50. According to the given question. Now, anyway, we have Okay, 0 point, small ones, right? 0.75% means it's not
Yeah.
70% as well. No, that is 0.75. 0.75 means it's like out of 100, oh, it is 0.00. If it's 75% and the 2.25. It was found that toxins made up between 0.75% of the mass of N of these samples used. Okay, so that means here it was found that toxins made up between 0. මෙතන දැන් මට තියෙන issue එක here toxins made up between 0.75% එකක් එන්නේ කොහොමද? So here it was found that toxins made up between, that means the gram, no? It should be like gram, right? Yeah, it was
Yes.
found that toxins made up between 0.75 and 2.25 kilocuanone, then acceptable. එතකොට in grams it would be in between 0.75 and 2.25 in the of the mass of N of this one. 10-gram sample. 10-gram sample. So use your curve to estimate the value of N. I'll keep it and think later. According to the
Okay.
question, it's like giving wrong impression. Did you do the 13th one? No, right?
No, not yet.
Okay. Just do that one, then we'll move to the next part.
Okay, teacher.
Okay, that is done. Then what else? That question is easy, right? Easy means
Yeah, it's fine. It's just analyzing.
okay. So explore 3.2. Can you predict what results? Okay, just rate this one and check whether can you predict what the results will be for any set. Okay. Explore 3.2.
Okay, teacher.
Okay, that's also fine. Then for the last theory part, we'll do. Here we have the variance and the standard deviation. Now we are done with the range and interquartile range, everything. No, so now we have to do the variance and the standard deviation. So what it says. So here what it says for the variance, in the Explore 3.2 activity, you discovered that the mean deviation is not a useful way of measuring the variation of a data set because the positive and the negative variations cancel each other out. So if we want a measure of variation around the mean, then we need to ensure that each deviation is positive or whether it's zero. We can do this by calculating the mean distance of the data value from the mean, which we call the mean absolute deviation from the mean. That means let's assume we have 10 data points x1, x2, x3, x4 up until x10. Let's assume we have 10 data points. So first thing we need to do is we need to calculate the what we call the mean of these values. That means we normally call it as x bar.
Yeah.
We just add all these values together and divided by the 10. Then we have x bar. That means the mean of this entire data set. Then what we do, we have to take the absolute deviation. That means the positive value of the difference of each data point with this x bar, which means mean. That means x1 minus x bar, x2 minus x bar,
Mm.
x3 minus x bar.
Okay, so even if x bar is larger than that value, we take the positive.
Yes, that means x10 minus x bar. Anyway, we are taking the absolute value. That means the positive value. Okay.
Okay.
So
Okay.
then we need to add all these values. I mean the differences. So now all the values will be positive. Ne? So we have
Yeah.
to add all these values together and divided by the number of elements again. Number of elements is here for the example, it is 10.
Mm.
Right. That's what here they have mentioned in this notations. With these notations, that means if I write it properly, sigma I is equals to 1 to 10. That means all these ones refer to all these data sets. Then xi minus x bar k absolute difference should divided by the number of elements. That means
That sign is modulus, right?
Sine is modulus, yes. Sine
Okay.
is modulus. That's what here we have. However, it is hard to calculate this accurately or efficiently for large sets of data, and it is difficult to work with algebraically. So this approach is not used in practice as well. Alternatively, we can calculate the squared deviation. So anyway, this method is the mean absolute deviation method. Mean absolute deviation from the mean. Why we say that from the mean? Because we are taking these distances or the differences with the mean compared to mean. අපි හැම එකම we are getting අපි subtract කරලා ගන්නේ with compared to x bar. X bar means the actual mean or the average. So, however, it is hard to calculate this accurately or efficiently for large sets of data, and it is difficult to work with algebraically. So, this approach is not used in practice as well. So, because of that, we have another method as alternative method. There we can calculate the squared deviation. So, there we are calculating, we are not taking the absolute difference. We are taking the squared deviation. That means x minus x bar squared. So then again, what will happen? Though it's an actual positive value or a negative value, anyway, when we squared it, it will be squared, then it will become a positive value.
So, isn't it pretty much like same? Like, or the
No,
only
no,
thing
here
is
we are not squaring.
square.
No. Here
Yeah, yeah.
we are not squaring. Here we are taking the degree 1 value. Degree 1 means anyway the difference. We are directly like if it's negative also, what we normally do, we just add up. මෙතන තියෙන්නේ එකයි. But here we are squared it. So this is more accurate actually. When we square
How is this more accurate?
more accurate means anyway we are taking the what we call the difference in actual value, no. So anyway, if it's negative 10 nang, we are taking it as it is negative 10, because in future you will be learning from this tamai we are generating the variance equation. So there's a proper equation to find out variance as well. ඒ කියන්නේ, so from this තමයි we are build up that variance equation as well. So this method, anyway, it would be much accurate actually. Make
Oh,
we are not getting kind of an proper answer. ඒ කියන්නේ කොහොම කරත් negative differences තිබ්බත් what will happen, it we without any proper calculation, what we normally do, we just make it positive නේ. හැබැයි අනිත් එක in maths how we solve the මොනවද modulus ones. One method is actually both sides we are like squared both sides and then find out all the solutions, right?
Yeah.
I mean, if we have like modulus x minus 1 is equals to somewhat like හිතන්නකො නිකන් දෙකයි කියලා, then what we normally do, we just squared both sides and remove this modulus mark, and then we'll like take this to the left hand side and simplify. That's the method නේ. ඇයි අපි එහෙම කරන්නේ? Why we do it like that? Because actually that is the what would say most accurate method. Then it will provide us kind of a proper answer.
So I should remember the second equation.
Yes, you should remember. But if they mention to use the mean absolute deviation method, then you can't go with the second method, squared method.
Yeah.
You should go with the first method. Because
Okay.
anyway, when it comes to error, so you will learn this part in future as well. So here the variance means actually the error. Error means the difference in between data points and the means.
Yeah.
Maybe sometimes there are like multiple methods to calculate this error. One method is mean absolute error. The other method is mean squared. Squared deviation one. That's what we have here with the x minus x bar squared decay. The other method is the standard deviation one, which we have like first we have to calculate the squared, and then you should divide it by number of elements, and then you need to take the square root of that. There are like three methods. පළවෙනි එක, we have what we learned already, that is mean distance. You can calculate the mean distance of the data point. That means mean absolute deviation from the mean. Then the second one is to calculate the variance. How we gonna calculate the variance? We are taking the differences in between data points and the x bar, what we call mean, and then we squared each value, and then we add all these values together, and then we divide it by number of elements. That's the second method. To calculate the standard deviation means the square root of this entire variance. Variance square root එක තමයි, we call it as the standard deviation. For measurements and the deviations in meters, say the variance in m squared. So to get a measure of variation that is also in meters, so here it's degree 1, but here it's degree 2. Then if we wanted to make it like degree 1, then what we have to do again, we need to take the square root. For that square root value, again we have given a special name. That's what we call the standard deviation. එතකොට again it will be degree 1. ඒ කියන්නේ degree එක එක වෙච්ච equation එකක් තමයි then we'll receive. So to get a measure of variation that is also in meters, because earlier it was m squared, now it's in meters, we take the square root of the variance, which we call the standard deviation. This looks no easier to calculate than the mean absolute deviation from the mean. However, the formula for variance can be simplified. See appendix at the end of this chapter to give. So then this variance, this equation actually, we can simplify it or narrow down to this equation. How we can do that? We can find the variance and the standard deviation from these ones. Okay, I'll show you how to do that one first. ඕන වේද දන්නේ, but anyway I'll show you. So here what will happen? Let's assume, so now what we have here is sigma x minus x bar squared divided by n. That means sigma is there. Then we have, if I remove the brackets and write it, x squared minus 2x x bar minus, no, not minus, x bar squared, right? That's what here we have, and then we have to divide it by n. That means we have sigma x squared minus sigma 2x x bar plus sigma x bar squared divided by n. Now what will happen? Sigma x bar means actually that is there. Okay. Sigma x bar, it's same as that. What do you think? What will happen here with this? Now 2 is a constant. No? X bar also
Yeah.
constant. So we can take that 2 x bar out, and then the rest we can consider it like this. හරිනේ හැම value එකකින්ම 2x bar means actually a constant. එතකොට then we have to take this හිතන්නකො නිකන් here we have 2 4 6 වගේ තියලා if we wanted to add all these values එතකොට I'll take 2 out and I'll make it as 1 2 3. එතකොට what I do, I'll just add all these values together and multiply it by 2. ඒකත් හරිනේ. So that is
Yeah.
the method here also what I have done. Sigma x, I'm adding all these values together and multiplying by 2x bar. Plus here we have sigma x bar square. Sigma x bar squared means actually, I don't know whether you noticed it, that is nx bar squared. Sigma x bar means here x bar plus x bar plus x bar plus. Likewise, we have n number of terms.
Yes.
We can rewrite it as nx bar. If it's nx bar squared terms, now then we have x bar squared terms. It's
Okay.
like this. So because of that, I can rewrite it as nx bar squared, and then as the denominator, we have n. Now, what will happen here? You know that x bar is equals to sigma x divided by n, right? Then,
Yes.
instead of this sigma x, we can replace that sigma x by what? Nx bar.
But
I can cross multiply these two.
yeah.
This means that I can easily replace it like this: sigma x bar minus 2 x bar squared n plus nx bar squared divided by n. Now, if I simplify these two further, then we have sigma x squared over n minus what will happen? X bar squared. I may then now simplify karam. Here I am getting minus nx bar squared. Then that nx bar squared, if I divide it by n, again we'll receive this x bar squared. Is it clear for you? Can
Yes.
do it by yourself. Just try the proof, because since they have mentioned it that they have given it in appendix, it's better to do at once. What? Let's do that.
Okay.
If it's not clear, let me know. No problem.
Okay.
ඒක නිකන් mathematical part එකක් වගේ තියෙනවා. Just nothing stacked in there.
Okay, teacher.
Okay. So did you receive the answer?
Yeah.
Did you did the proof, right? Okay, then to find each values, okay, up to this point now it's clear. No? So according to the data set, we can find out n number of elements and sigma x as well as sigma x squared as well. So by finding these values and once we substitute these values, we can get the final answer. Okay, yes, here a low standard Here, a low standard deviation indicates the most values are close to the mean, whereas a high standard deviation indicates that the values are widely spread out from the mean. Consider a drinks machine that is supposed to dispense 400 milliliters of coffee per cup. We would expect some variation in the amount dispensed. Okay, that's what here, this is kind of our practical scenario what we have given. Okay, that's it. Yeah, we can continue next day. If you have time, just go through with these worked examples. And also there you have another exercise as well to do. So yes, from this theory, we'll start on next day. That's fine.
Okay, teacher.
Okay, no problem then. See you next day.
Okay, teacher. Then thank you, teacher. Good night. Bye.
Right?